Sauce here. This is a video lesson on the concept of period. Cyclical functions are functions that repeat a pattern or cycle. Cyclical functions have periodicity, meaning that the space that it takes to repeat a single cycle of a cyclical function is called its period. To show you what I mean, I'm going to create a cyclical function. This function looks piecewise if it has 3 linear pieces. And if I repeat this pattern, then I can observe this function to be cyclical. It has a cycle that repeats. What's this function's period? If I select a point, any point, and I think of going through the pattern of one cycle, whatever that pattern may be, to get back to the beginning of the pattern or the beginning of the next cycle of the pattern, then the interval in the domain, or the space in which I needed to create that one cycle, would be called its period. If I count 1 for every box, then it took me a space of 4, or an interval size of 4 to go one cycle, so this function's period is 4. I could have started at any location. This time I'm going to start at an intercept, and the space at which it takes to go one cycle back to the beginning of a new cycle, which I will highlight here, is also the space of 4. No matter where I start and stop, if I complete one cycle, then the period will always be the same. The sine function has a period of 2 pi. Cosine has a period of 2 pi. Sketching parent sine, the space needed to repeat one cycle is the function's period, and if this was sine, then the period is 2 pi. If I start at 0 on the midline, I get back to the beginning of the cycle at 2 pi. Knowing that a function is cyclical and knowing its period can be very helpful. If I call this function the f function, and I knew its period, then this is what's true about the f function, that the value at any place is equal to the value at that location x plus any number times its period. How is this helpful? Well, in this case, the f function has a period of 4. We could say p is equal to 4. And if I wanted to find the value of this function at 42, this number that I'm looking for the value at is so high, it's off my graph. I can't read the graph directly at 42. But with the concept of the period, the value of the function at 42 is going to be the same as the value of the function at 2 plus 10 periods of 4. 10 periods of 4 is the interval of 40. Add 2 to that, I get 42. So I'm going to find the value at 42 by looking at the value of the function at 2. The value of the function at 2 is equal to the value of the function at 42 because 42 is 10 complete periods over to the right, but it comes back to the same value. The value at 2 can be observed on the amount of the graph that's presented. Let's do this with a sine function. If I wanted to know what the sine of 7 pi was, I could think of it as being the same value at pi plus 3 periods of 2 pi. A cyclical function, one that is periodic, means that it's going to repeat its values. So if I want to read the value of sine somewhere that's off my graph, I could think, how many complete iterations of the wave can I ignore and find my value from what's left? The sine of 7 pi is equal to the sine at pi plus 3 complete periods of 2 pi that I'm going to ignore. The sine at 7 pi is equal to the sine at pi, and I can read that from my graph. Pi is read right here and has a sine value of 0.